And welcome to your first part of your review session for your final for Math 152 College Algebra. We are so happy to be with you today, and I'm glad you could tune in. And we'll begin with this first problem. Among all pairs of numbers, x and y, such that 2x plus y equals 15, find the pair for which the sum of squares, x squared plus y squared, is minimum. Write your answers as fractions, reduced to lowest terms. So we're going to begin by first taking our linear equation, 2x plus y equals 15, and we need to solve it for x or y. Clearly, one of those is going to be easier to solve for here, and that is y. So I could solve this for x or y, get a variable alone. I'm going to solve for y. Y equals negative 2x plus 15. Now, it told me to find the pair of numbers for which the sum of squares, x squared plus y squared, is minimum. Well, if y is said to equal the quantity negative 2x plus 15, then I'm going to replace y with that quantity in my quadratic equation. So I'm going to rewrite this as x squared plus the quantity negative 2x plus 15 squared. Now, if I square a binomial, I know that I'm really multiplying the binomial by itself, so I'm foiling it with itself. So I'm foiling negative 2x plus 15 times negative 2x plus 15. So multiplying the first terms, I get 4x squared. Outer terms, negative 30x. Inner terms, negative 30x. And last terms, 15 times 15. That's 225. Okay, so this is going to equal x squared plus 4x squared. These combine to be negative 60x plus 225. Okay, I have another set of like terms that can be combined. X squared and 4x squared combine to be 5x squared minus 60x plus 225. Now, if I think about what this quadratic expression really is, this would be a parabola with a positive leading coefficient. It's smiling, and it asks me to find the pair of numbers for which the sum of squares is minimum. When it talks about minimum, we're talking about the minimum value of that vertex. Okay? So to find the x coordinate of this vertex, I use the axis of symmetry formula, negative b over 2a. So negative b is going to be negative 60 over 2 times 5. Minus a negative becomes positive 60. 2 times 5 is 10. So x equals 6. Once you find what x equals, to find what y equals, it's just like a system. We're going to substitute this back in for this x. So I go back, I'm going back and forth between the two equations. So I will say that y is equal to negative 2 times 6 plus 15. So y then equals negative 12 plus 15, and negative 12 plus 15 is 3. So if you go back and consider, before you submit anything in this test, you really should consider, does my answer make sense? So go back to the question and think about it before you just type it in and click. Okay? So go back and think about it. Does that satisfy this equation? If x is 6 and y is 3. 2 times 6 plus 3. Does that equal 15? Does it? Okay. And if I square, x squared would have been, what, 6 squared? 36. And y squared was 3 squared, which is 9. 36 plus 9 is 45. That probably is going to be one of the highest values that I would get. Okay, so 3 and 6 are the answer. Now, sometimes you're going to get fractions here. If you do get fractions, submit it in fraction form. Don't try to give it as a decimal. Don't round. Okay. All right, moving on to the next question. Okay, and the next question asks us to solve the exponential equation. So I'm looking at a fraction raised to a power that contains a variable equals another fraction raised to a power that contains a variable. The idea here is that I would like to make the bases match. When we solve exponential equations, you can either make the bases match, or if you cannot, then you have to take the log or the ln of both sides. Okay, those are your two approaches. So making the bases match is friendlier and easier. When that doesn't work, then you take the log or the ln of both sides. So here, let's consider, I've got a fraction 2/3. 2 and 3 are both prime, so I'm just going to leave this as 2 over 3 to the 8x plus 14. So on the right side, I know that 27, if you know those key powers of 2 and 3, it really helps you out, because 27 is 3 to the third, and 8 is 2 to the third. So 3 to the third and 2 to the third would be 3/2 to the third power. I rewrote 27 over 8 as 3/2 to the third power, because 3 cubed is 27 and because 2 cubed is 8. Now that is also all raised to the x. When we have powers of powers, we multiply exponents. So this would be 3/2 raised to the 3x power. Okay, do the bases match? Not yet, but they're close. So what would I like to see happen here to make the bases match? I would like for one of the fractions to flip. Okay? Let's just work with this one on the right, since that's the one we're working with. If I flip it and write it as 2/3, that's 2/3 to the -1. 2/3 to the -1 is the same thing as 3/2. And then that's raised to the 3x. Okay. So again, I have powers of powers, so I can multiply the exponents. The right-hand side becomes 2/3 to the -3x is equal to 2/3 to the 8x plus 14. Now do the bases match? Yes. And since the bases match, we can let the exponents equal each other. So we can say that 8x plus 14 has to be equal to -3x. And this is the equation that we finally solve. So to solve this, I'm going to subtract an 8x on both sides. I get 14 equals -11x. Divide by -11. And x equals -14/11. There's the answer. Okay, our next example says to write the standard form equation for a line that passes through the points -12,6 and 0, -10. Write the standard form equation of the line. I recognize immediately that this is a y-intercept. anytime you see an ordered pair that has 0 for the x-coordinate, that's the y-intercept. So I know if I put it in slope-intercept form, it's going to be y equals something x minus 10. So really the only thing I need to find here is the slope. Okay? To find the slope, I'm going to use the slope formula. Slope formula is going to be x1, and you're going to use x1, y1, x2, y2. So the slope formula says y2 minus y1 over x2 minus x1. So my y2 is negative 10, minus y1 is 6, x2 is 0, minus x1 is negative 12. So I'm going to get negative 16 over 12. And that reduces to negative 4/3. So I got negative 4/3 x minus 10 as the equation in slope-intercept form. Careful, they put it in bold for a reason. They want my answer in standard form. That is ax plus by equals c, and you cannot have fractions in the answer. Probably the biggest mistake on this would be someone to get this answer and put it in and feel good about it. That's right, but that's not the right form. Okay? So, first of all, I will remind you that standard form can't have fractions, so I'm going to eliminate fractions here. What can I multiply this equation by to eliminate the fraction? 3. So if I multiply the entire equation, both sides, everything, by 3, I'm going to rewrite this as 3y equals negative 4x, because the denominator would cancel, minus 30. That is the result of multiplying the entire equation by 3. Now, what do I do to adjust this to put it in standard form? Standard form has ax plus by equals c. So this is in the wrong spot. So I'm going to add 4x to both sides. That gives me, in standard form, here's the answer, 4x plus 3y equals negative 30. That's the correct answer. 4x plus 3y equals negative 30. Okay, the next example says to determine the formula and the domain for f dot g of x. Enter your answer in simplest form and round your answer to 2 decimal places if necessary. We're also supposed to state the domain here of f dot g of x. So, f dot g of x, if f of x is x squared and g of x is x cubed minus 2, for f dot g of x, we're going to find f of g of x. So I'm going to call the outside function f of x and the inside function g of x. So first, I will rewrite this as finding f of, replace g of x with what it equals. G of x is x cubed minus 2. Now, finding f of x cubed minus 2 means replace x in the f function, so replace this x with the expression x cubed minus 2. So this would equal x cubed minus 2 squared. I squared it because the f function says x squared. Okay, so when I square a binomial, it says I have to simplify my answer. I'm going to take that binomial, multiply it by itself, so that is foiling it with itself. So x cubed minus 2 times x cubed minus 2. And I FOIL the result. So that would be x to the 6th minus 2x cubed minus 2x cubed plus 4. Combining like terms, I will get x to the 6th minus 4x cubed plus 4. This is the answer for f dot g of x. X to the 6th minus 4x cubed plus 4. The second part of the question asks me about the domain. So I will remind you that when we're stating the domain, our domain is always going to start as, you're always going to assume the domain is all real numbers, unless you have a red flag situation. The red flags are x in a denominator, x under an even root. Those are the only reasons that we're going to say the domain is not all real numbers. Do you have an x in a denominator here? No. Do you have an x under an even root here? No. So our domain is all real numbers. Okay, so the next question uses the same two functions, but it's asking us to do the opposite composition. Instead of f dot g of x, we're going to find g dot f of x. So, outside function now is g of, inside function is f of x. So g of f of x is what we're going to determine. We're calling f of x the inside function, and we're calling g of x the outside function. So first, I will replace this f of x with what f of x is said to equal, and that is x squared. So I'm going to say I'm finding g of x squared. I replace f of x with what the function is. Second, I will go to my g function. I will replace all my x's with x squared. So in my g function, I have x cubed minus 2, but that x is going to be replaced with x squared. So I have x squared cubed minus 2. Exponent rules. Power of power. What do I do? Multiply. So 3 times 2 gives me x to the 6th power minus 2. So g dot f of x is x to the 6th power minus 2. What about the domain? Are there any restrictions? Do we have x's under an even root or x's in denominators? No. So again, we have a domain of all real numbers. So x to the 6th minus 2 and all real numbers. Okay, this next question goes back to the very first lesson of the entire year. I'm so excited. We love this. Is this to simplify the expression. This is a complex number expression. We have division using I. I, remember, is the square root of -1. So what we have here is a square root in a denominator. We have to rationalize the denominator. The way that we rationalize the denominator is we multiply by the complex conjugate of the denominator, both in the numerator and denominator. So the complex conjugate of 7 plus I is 7 minus I. And I'm not allowed to multiply by some number out of thin air unless that is going to equal 1. So 7 minus I over 7 minus I is equal to 1. So now we break this up, numerator and denominator. In the numerator, I'm going to FOIL. 4 times 7 is 28. 4 times negative I is negative 4I. I times 7 is 7I. And I times negative I is negative I squared. In the denominator, you could also FOIL, but you might remember that when you multiply conjugates, the O and I are going to cancel out every time when you FOIL. So you can just multiply the first terms and last terms when you're multiplying conjugates. So 7 times 7 is 49. I times negative I is negative I squared. Now what do we know about I squared? I squared always, it equals -1. So we're always immediately replacing an I squared with -1. So this is going to become minus -1 instead of minus I squared. This is going to become minus -1 instead of minus I squared. And we know that minus a negative always becomes plus a positive. So if I look at like terms in the numerator, I've got 28 that combines with positive 1 to be 29. And I've got negative 4i that combines with 7i to be positive 3i. In the denominator, change it to plus a positive. 49 plus 1 is 50. There is your answer. 29 plus 3i over 50. Okay, this next question asks us to use the properties of logarithms to expand the expression as much as possible. Simplify any numerical expressions that can be evaluated without a calculator. Okay, so the first thing I notice is I've got a big division problem here. Log with divisions, or ln with division. I can use the quotient property to rewrite this entire expression as the ln of x to the 8th times the square root of p to the 7th q minus, everybody following here, ln of e to the 3rd power. Now what do we know that ln of e to the 3rd power simplifies to equal? By our properties of logs, that cancels. We end up with minus 3. Sure. I also notice that I have this x to the 8th power that is being multiplied by the square root of p to the 7th cube. So by the product property, I will rewrite this as the ln of x to the 8th plus the ln of the square root of p to the 7th cube. Does that make sense? Okay, next, I'm going to apply the power property. This 8th power, I'm going to bring down as a coefficient. Write this as 8 times the ln of x plus, I'm going to rewrite this p to the 7th q instead of being square root. I'm going to change that to the 1/2 power. And then the 1/2 gets to become a coefficient times the ln of p to the 7th cube. Okay, now I'm going to apply the product property again because I've got the multiplication of p to the 7th cube. So I'm going to write this as 8 times the ln of x plus 1/2 times the ln of p to the 7th plus 1/2, because that was still part of this expression, 1/2 times the ln of q minus 3. Last, I have another power. I can multiply 7 by 1/2. So I rewrite, this should be my last step. I'm going to say 8 times the ln of x plus 7/2 times the ln of p plus 1/2 times the ln of q minus 3. That is fully expanded. Okay, next question. Considering the following functions, identify the basic function that has been shifted, reflected, stretched, or compressed. Cube root of x. Okay, next part of the question. It says, considering this function, indicate the shape of this function. What is the general shape here? And what we will do, since this is your review notes, and you know on the final you might get a different type of function, you might not get a cube root, we'll identify each of these shapes. So the first one is a parabola. What type of function is that? X to any even power. Okay, x squared, x to the fourth, x to the sixth, any even power. Second one, x to any odd power. X to the third, x to the fifth, x to the seventh. Third one. 1 over x to an odd power. 1 over x, 1 over x to the third, 1 over x to the fifth, any of those. Fourth one. 1 over x to an even power. So 1 over x squared, 1 over x to the fourth, 1 over x to the sixth, any of those. Next row. Square root. Square root, fourth root. Any even root function. This one is the cube root, so this is what we're looking for here. This is our answer choice. Cube root, fifth root, seventh root, any odd root. This is absolute value of x, and this is the greatest integer function. Okay, this question is asking how this particular function has been shifted from its parent graph. So, how has this been shifted, reflected, stretched, compressed from its parent graph? So, what do we know about a negative in the front? What does the negative in the front do to change the graph? Which kind of reflection? X-axis or Y-axis? X-axis reflection. So, it's going to have an X-axis reflection. What does it have to have in order to get a Y-axis reflection? A negative on the X, and it doesn't have that, so we have no Y-axis reflection. Okay, what about a stretch or a compress? Do we have either of those? Which one? We have a stretch by what factor? By a factor of 2. And notice that you don't use a negative there. Okay, stretch by a factor of 2. What about a horizontal shift? Do we have a horizontal shift? It's going to go left 2 units. And what about a vertical shift? Down 4 units. And then it will graph for you. Last, it's going to ask you about the domain and the range. What I recommend is that you go back to the graph on the previous screen to identify the domain and range. So if you go back to the graph and look at what the computer has graphed for you, this is the graph of the function based upon the shifts that you gave. For domain, imagine flattening the graph to the x-axis. If I flatten this on the x-axis, it's going to go forever to the left and forever to the right. So the domain is all real numbers. For range, imagine flattening it to the y-axis. So on the y-axis, if I flatten it, it's going to go forever up and forever down. Very slowly, but forever up and forever down. So the range is also going to be all real numbers. You can also think about the fact that there's no red flags here. There's no x's in denominators or x's under even roots when you think about the domain. Okay, so the domain and range are both all real numbers.